Alright guys, welcome to Capstone Day. We have all of our students setting up their posters, so it's kind of place off the time their Capstone project. This is really exciting to see the culmination of about a year's work of just working through some posters and come up with something that is new and helpful. And so really exciting to kind of let them see the shine in their eyes. Their project that they had, even with completely like the original design.
So, I mean, what comes with this?
I hope you enjoy the tour. So this is an automated attendance system. Our program does not store data so we'll take pictures of students' faces and store that in the database, and it's a very dynamic display that they have here. If it recognizes your face, then you add it you are. If not, then you add it
Normally it'll start recording over here, and after it starts recording, it'll take video. For some reason it glitched out, but before it would move around and you can scan these faces. It recognizes any face as a face, but only us two are in the database as pictures. So you took a picture from this angle, the diagonal, and then a straight horizontal, and then did that on both ways. So when it goes to the camera, it'll say our name on the head, and then that'll go.
We got right here.
This database right here.
We got
with the date and time that is taken.
I think that's an idea.
And this makes a new file every day by itself. Or that specific day. So the next day, we make a new file, and then you have to read the text for that specific day.
Pretty cool. All right.
I don't know why it crashed.
It's all good. Thank you guys.
Where you can create side master plans for any mod in the United States. If you know what a side master plan is, it's like blueprints for a specific area. So the reason why we wanted to do this is that a lot of Americans rural, specifically a lot of Alabama's rural, about half of Alabama lives in overpopulated areas, under 1,000 people. So we created an online website for those people who don't have access to the great side master plan services that people in higher populated areas do. All you have to do is enter an address, pull a lookup. It uses two different APIs to get geolocation and parcel information. Then you enter the number of buildings you want on the lot for the blueprint, and then further down there you input what type of zoning you want, residential, tenancy, residency, mixed use, commercial, and industrial. After that, you can generate image. It gives you a little prompt to show you what the AI is going to generate, and then it actually creates the site.
Pretty cool. Thank you guys. What you got?
Tell us about this.
You can see it's all kind of moves. This is to collect better efficiencies. Because when you're talking about residential, you have them usually like 45 degrees on the roof, right? So they can only collect sun until the sun's like even with them. So that may only be like 6 hours a day of sunlight. Whereas this, we can get like a full 12 hours, which is theoretically more efficient. And so I can talk to you a little about the life cycle of the project. The energy starts here. It's basically just we'll go to a 12-hole battery. Turbo right here, and I know the wiring is messed right now just because I had to tear it up for our demo, but you can look right here, you can see that all the coding was there. So if we did the math for estimated what's its earn, so when we consider our component use and like the greater amount of time that we get from transfer, it's about a 30% increase just sitting flat 45 degrees. However, when you usually talk about solar panels, you think of cost effectiveness because your goal is to use it for your own home or use electricity bill, right? So in that situation, this thing takes longer to pay for itself than a roof panel. However, in a situation where that doesn't matter as much, and you maybe you're off the grid, that you just need like literally more than this is your off the grid. And then you can stack a bunch of this, and maybe not necessarily just be off the grid. But if you're okay, you simply just want more electricity, or are okay with the cost difference, and this is your option.
Awesome. Perfect. Thank you.
How's it work?
So it's expensive to food at a set time. The app is So it dispenses a set amount of food at a certain time that is at the bottom. This is the website that we created.
The pie itself has a little bit as well.
The target weight was 30 grams, so it's a little off.
So is it dispensing food and measuring it as it goes, or using a predetermined amount? Like so many rotations internally.
The actual bottom we get an average amount calibrated for.
It's very interesting.
So we're live streaming this. So yeah, if you want to talk about your project a little bit.
So, this is our project, Media Tavern System, named after a common joke in D&D that every campaign starts in a tavern. Everybody in our group plays D&D, and we love D&D. But in-person D&D has some issues, mainly cost and minis, which are typically used for characters and representation, or just getting more expensive at the end of the day. And maps take a long time to draw or set up, and then just switch them out during the evening, it can be a mess. So, our system aims to fix it. With our system, you can get a digital download online, just as a payment, and upload it to the community tab system. So, for instance, if I go in here, I can select choose a file, and we have a standard. So this standard 11 by 16. I can grid, 11 rows, 16 columns, and press change map, and that changes. As for the mini problem,
You can do the same thing with heritage tokens. For instance, here we have not a D&D character. This is that's placeholder. You can drag this around, and then from there it's as simple as playing D&D, rolling dice to hit enemies, skill checks, the standard.
So basically, the gist is Guitar Hero with an actual guitar.
Oh, cool.
So we just run through the software to pick up when you play the guitar, make it button input.
Very cool. Thank you, guys. Can you tell us a little bit about your project?
So basically, it's like
stuff like that. They won't be based, they won't be operated independently. You can just see an emergency there. I might try to kind of the same way our interstate system was designed. Most people don't know.
Sorry, go ahead.
So you point it at something and it measures the distance between that up to 15 meters. It's for archery. So the lane is 10 meters.
Just like right now,
We don't have the battery in the game now.
because I'm growing it out, but I just need like.
Very cool. Thank you, guys. And, all right, can y'all tell us about your project?
So we realized that there was a problem with their phones while we studying. They would have it. They easily get distracted by a notification on their phone, whether it be an email or a text message. That could potentially lead them to go down other roads on their phones like social media. And so we want to
I'm like, I guess I'll just keep going.
so we think this study
So basically, tons of paperwork is very tedious. What our study buddy does is it uses things you try to do yourself. If you want to do a check of the weather is, or the time is, or if you want to change the song that you're listening to while studying, you can just tell buddy a simple command like, hey buddy, change the song to a Radiohead song or a band you like, or anything like that, by using API keys online and accessing that. And it also utilizes a lot of text-to-speech prompts that are actually OpenAI AI API keys, which we had to get tokens for.
And the ultimate goal is to help students stay proactive in their studying and so they don't go on Instagram and other devices.
Awesome.
On the table, you can try to see the evolution of our prototype of Buddy. And so firstly, we were just trying to think what looks good and what's practical. And so our first model was just something to get us into the game. And then our second model is when we started getting serious. And so this white ball actually was going to be the speaker itself, but this was going to be a charging dock for the station, so Buddy could be portable. And then our third model is when we kind of took towards a different shape because we realized this wouldn't be feasible within the time constraint. And so that's when we got to our final design at the end. It fits all of our parts inside, and it's easily transportable.
Very cool. Awesome. Thank you, guys.
Thank you.
Hello. Can y'all tell us a little bit about your project?
Radio module, we call it ears, enablement portability with radio module.
band. You see your cards. Now on there,
what
the
it
card
does
number
is
is
it allows
off
you to
compared to the
prevent
actual
off
poster is.
grid and
Because when we
access
first
to
calibrated this, we didn't
weather
have the
apps.
extra way
You have
like
access
the
to
top and
real-time weather data.
So it's off.
It also offers
So the next step is you shuffle the cards.
You can tune into your radio and broadcast.
Yes, you can't shuffle, but if you could, you have to.
And the operating system is entirely, we made our own operating system from the ground up, and it's actually open source on GitHub. So it allows you to download the code base, schedule components, and build it from the ground up to suit your needs.
When it wasn't glued on, I'm teaching when it worked.
Okay.
We were drawing. I was like, wait, that's cool. Yes, it is.
Weather menu. There's a sensor on the inside that's reading the weather data from the room. So it's all like local data. It's not a sensor like placed like 50 feet away. And then this is the radio menu. It's hard coded to auto set itself for the school's radio frequency. But you can go up and change it. And it'll go from 108 all the way down to 76.9.
Very cool. With all the crazy weather we've been having lately, like it is so needed. Exactly, and it's probably more accurate. So, thank you guys. Hey there. Can you tell me about your project?
Automatic card shuffler with weight detection. And so the reason why I made this project is me and my partner Trey is not here, but we love to play cards. And our opponents, they would always cheat, tamper with it, hiding cards under the table in their pocket. And so we want to change that. And so that's what we decided to make. The automatic card shuffler, weight detection to prevent tampering. And so how it works, you would on the touchscreen, it loads up and you see it says place the full deck weight on tray, and we have two options for plastic or paper. Basically, whatever game you're playing, poker, blackjack, you just take how many cards you need for it. For this, and since this is your the cards you're using for the game, this is your reference. You put this on there, and then you set your deck weight. So this is your weight, like I said, your reference weight that you use for the whole entire game. So you're at the game, every time you shuffle, you'll go back to this weight to see if the cards are tampered with. If someone took away a card or added a card. And so, this is your deck weight. When you're going to shuffle, now the shuffle part doesn't work, but if you did, you take it to the card space, take the card space, put them on there, and so then you shuffle the deck and you wait, keep waiting a little bit longer, maybe just one more second. And then as you can see here, since no cards were moved, the thing says the deck has not been tampered with. And so that means the card game is good. If I were to take away one, shuffle it. And remember, it's still using that same reference weight. Shuffling. The deck has been tampered because I took away a card.
Oh, wow.
That's our Capstone product.
Awesome. Thank you so much.
So they did not succeed.
It's on YouTube.
Smart water head. So it takes inside the sensor and then sends it to the website to try how much water it's
We also do sometimes save data as well as like a time lapse. Basically,
so as you can see, it just ran. It updates every 30 seconds, and once every 30 seconds, did it all over the model, so it's on 0, so it doesn't cause an error. So in 30 seconds, you'll see that how much water is in the bottle and how much water is in
So it's basically, it did its
Because we've been demonstrating this multiple times. At the very bottom there is the amount consumed total today. I actually haven't coded each of there, but it's released every 24 hours. But if you look over here now, with the water that we changed, there's now only 6.7 ounces in the bottle. And it changed the amount of water that was consumed.
want to get more out of it.
One of the more unique things about this project is that it is incredibly encrypted when it comes to cyber aspects. Three things that have to be true in order to access this. One, you have to be physically plugged up to the device to be able to run the code, or even access the code, really, and access the website. Then the website itself is hosted on my personal laptop's local IP address. And then once you have that, the only way to get the website to load is to connect to the microcontroller's personal AP Wi-Fi network, which is protected by a 25-character hash. There's absolutely really no way to get into this without having both physical access to the device and knowing a really long password.
Keeps the history of all the water you drink and all of the updates. And one of the unique features about this is most of the smart water bottles on the market right now cost $100 to $200, and this we made for less than $100.
Very cool.
The actual materials in this bottle itself are maybe $20. Between the PLA, the ultrasonic distancing sensor, the wires, and the Pico itself, maybe $8 for the bottle, less than $1 for the 3D printing.
We 3D modeled this koozie that goes around the bottle, and then we also 3D modeled on Fusion 360 this protector for the ultrasonic distance sensor. And these are some of our prototypes for what this koozie ended up being.
And so also 3D printed the game.
Awesome. It's a great project. Thank you guys. Appreciate it.
Since you're using ham radio frequency, you cannot encrypt it. So, there is alternatives to the ham radio network. You can use satellite. Satellite is very expensive, but you can use it for that sort of purpose. You can use commercial radio. You can use LoRa radio. LoRa radio here is Mesh Caster. Mesh Caster is sort of a non-ham radio Bermuda license. It's sort of a private license. And mesh casting uses LoRa radio. And so you can use a LoRa radio. The LoRa radio is going to transmit a bunch of data. They don't have
Hi guys, can y'all tell us a little bit about your project?
The way it works is if you're going to have a reader or a tag, a fingerprint sensor, then we said it'd be more secure to have it on the tag because if someone breaks into a reader, then it's going to be like mass compromised, and basically anyone can get in undetected and mostly disabled. And plus, doing it like this means you don't have to read a bunch of really expensive information. So you have your fingerprint sensor running with this, and then you put it on this millimeter, and then you go say that.
Awesome.
So this is the code that we use so the tag, so this was a prototype, and this is on the wire, this is the fingerprint sensor, and this is the tag, so you tag this first, and this will be unique to you, to a user. So once you type that, then it'll pop the fingerprint, and then
Awesome. Thank you. Hey, can y'all tell us a little bit about your project?
Is basically we have the automatic planter. Like it's the sensor thing we call a plant echo. Basically what it does is it takes about input from 5 different sensors and it tracks them. And then with this screen and the LED, it'll tell you like if it looks good, if it has enough light, if it doesn't. And with this dark mode, you can see all of the
Awesome. Perfect. Thank y'all. Hey there. Can you tell me about your project?
So we wanted to make it cheaper, but with be able to do basic things. So we tried a ton of different designs, finally landed on this one. And fortunately it didn't end up working because we needed the power with 2 different batteries, but we only ended up using one because we thought that would work. So we didn't have enough voltage to go with motor. And it would have worked as well. It would have worked if we would have done that.
Thank you. Hey there, can y'all tell us about your project?
This is your like laptop. This is secured by a battery pack. It's in your pocket. And then with your phone, we have a web interface. Basically, the phone connects to this, and this has like 12 hours. You put this in your pocket. You know the amount. Open plans.
Yeah, so the way that it works is the device, which right here we have our laptop for our head. The Raspberry Pi is the final product that you buy. It has a Wi-Fi node on it, and that runs a hotspot. So your phone connects to the hotspot, or you can control the device and make it connect to the network, so an Nmap scan, do any kind of like network penetration testing. So, for example, he unlocks the so he's gonna hit the reboot button on our interface, and you should see pretty quickly the laptop. There it goes. It turned off. It starts running.
Awesome.
You can give any command in, you can ready
And so that way you're able to do penetration testing and things like that without having a laptop. You can just use this that fits in your pocket. And
Perfect. Awesome. Thank you guys.
check out Amazon.com. It's $30. We wanted to make it accessible for people to, if they wanted to follow along. So we go through. Someone did put the link on there, so you have to look for this manually. It's all instructions if you ever want to follow it. So we documented it. So
Can y'all tell us about your project?
very cool. I can tell you about all this information. Charge you guys this costumes we're taking. On this costume, around $300. Not exactly how. Mainly because the costume wasn't safe, so plastic. It was a very complicated process, design-wise. It went through a lot of iterations. More improved design. So the screen, it's going to tell you, like right now there's no water, and so it tells you when you put your water bottle, because water level sensor, there's no water, so it's not here, getting any data, and so it's telling you when you put your bottle. And then with the water in there, if it's like a unclear color water that's like clear, it'll tell you to refill it, change the water, because and so once you change the water, and then like if there's water in there, the water's clean, they'll tell you no good. So you stepped up though, you wore the outfit.
All right, thanks, guys.
Yeah, if that's something that I could definitely be like, if they come with
I'm the person who needs tips.
I mean, this is the page that when it tells you what's what, once your sensor is in your tray, but it will tell you data gathers, and then if it's a VIP, it's not much about it, and then it just sells it to general stuff. I put it here for working plans, has a page, so
Was this live?
yeah.
I didn't realize this app was live when you were showing me. Okay.
In the future, I hope that you have more plans, and then other things to go to log in, log out functionality in case you don't want anyone to see your plans. And that's the app. So altogether, it's kind of supposed to help you know what's going on with your plan and know what to do about it. It's good for beginners.
Have you ever made an app before? I didn't think so.
I learned this all by myself.
For the purpose of this project.
Yes.
Originally, this is what it was supposed to look like. This is supposed to be like a little bit more like my phone. This one has a pH, it was supposed to have a pH sensor, and then you have a battery here because we kind of wanted it to be like a standalone device and then you pull out your phone and things of that nature. But within our time constraints and also due to this storage implementation of the pH sensor, we weren't able to get that running. And so we just kind of made it
Hey guys, can y'all tell us about your project?
The problem that we're facing is that college students face transportation issues, whether it's public transit, transit's not always reliable, whether it's money or you miss the bus. Electric scooters, they don't have the same efficiency as a regular bike. You don't have everywhere. Walking takes forever. And you can't really drive far that much on campus because of parking and everything. So we're trying to make an electric bike because that would be efficient. And most electric bikes on the market are like $3,000. And so we're trying to make one for cheap. And so we spent about $600 on the whole thing. But that was, we bought the actual bike too, like $150. So if we didn't buy the bike, to convert a regular bike to electric would be like $350. And so we have like a step-by-step process. And so like we could really show it how much it has to turn into a bike, an electric bike for like $350. And then the top speed we got to was about 22 miles an hour recorded, but that was when we were going from the road, so we had to like stop everything. If you have like if you're just going straight line, like no stopping, I think we top out like 25 miles an hour. And so for the price, it's pretty efficient. You know, you can get license plates, you get a regular bike wash, which would be good. And then so the battery life is like 3 hours. So that's pretty solid too. Definitely take it to a few classes. And if you just drive to a class, turn the battery off, park it, you can probably make it through all your classes and you just go home, charge the battery. So,
very cool.
We got a speedometer here. You see the speed. You can turn it on, turn this on, turn this on. You can up the mode to how fast it goes, and or how much throttle you give. And based on like how much you turn it on, is how much throttle you give.
Very cool. Thank you. Hey guys, can y'all tell me about your projects?
Yeah, so basically, basically we created an active damper to put on the bike so that when you hit the front brake, it stiffens and it doesn't compress as far under it doesn't compress as much under braking.
Usually when you hit the brakes really hard, you get this kind of really sharp compression in the suspension or dive. And so all this is doing is just slowing the suspension down and making it a little stiffer to stop like diving on the brakes, which helps with stability.
What are all them?
So these are different renditions of the clamps that we use to put on the cylinder. We've used various ways of filling the thing up with air, but we ended up switching to hydraulics instead of pneumatics. And this is the valve body that we've used to switch the direction of the flow, changing from a restricted to an open path.
Very cool. Thank you guys. Can y'all tell us a little about your project?
Old projects, you know, that we just started to, you know, that we don't have a studio yet, but we hope to do
Are these, what are all these wires?
What's up?
What is all of this?
So this is the batteries, these are power sources. We're not connecting it right now because we don't want to cause an accident here. But we have power source. This leads to our step motor and our relay, which is the 9-pound wiring here. Because that's how we want to put it up and that's how we want to turn it. It requires an extensive power source. But we're not a little brains in the machine, which holds our code, things like music. That's one end right here. Our code, which is our the brains of the operation.
Awesome. All right. Thank you guys. All right, guys. Can y'all tell us a little bit about your project?
Okay, so this is prototype. Because Donald Trump implemented some unfavorable tariffs and we could not order from Taiwan.
It's pretty sad.
It made it so recently, the price went up really high for shipping and everything, and so it didn't really shipping time. So we decided to stick with the fuzz aspect. Basically how it works is the guitar signal is assigned with, and what our pedal is doing is clipping off the top of it, which gives it like a warm kind of sound. Typically you hear it inside of Smashing Pumpkins and Joy Division, those kinds of bands. Big on the 80s kind of thing. That's our pedal.
Big in the 90s, shoegaze. Pretty great level. They're wired in series, not parallel, so they compound each other rather than running parallel. But the circuit works. We got it tested out. We just couldn't get the PCB.
Awesome. Perfect. Thanks, guys.
You know that's really dumb because you might as if you're marking each one with a different color, you might as well just sort them manually. Yeah. Those have been completely done. This isn't full speed, we don't have much room, but
Imagine needs like puts up in like the file cabinet or something, and you have like.
But this is what we want in the future. We obviously take it bigger, but we don't have a budget.
Yeah, it just flips. So basically, like put all like just did it down on paper.
That would be really nice.
And if I fill some paper, put it there, and just feeds into each part of the file cabinet. Imagine. It's not tough.
It's pretty tough. That is all the more intense.
There. Can you tell me about your project? Can you tell me about your project?
Yeah. It's a automatic paper sorter thing. So basically, it takes paper, it sees a little color in the top corner, and then it sends it to the machine and puts it into like one of a couple drawers based off the color. And then this arm moves up and down to move into the different parts. So it's just, yeah.
Perfect. Thank you. Hey there, can you tell me about your project?
Okay, so basically it's a digital prayer box that it's a prayer box that we're selling. So basically all you do is you submit a prayer and then it will get approved by an admin and then it will pop up back on the dashboard for other people to pray.
Awesome. Thank you. Hey guys, can you tell me about your projects?
And it's just a cheaper alternative. Our graphic is small business owners. We're preparing for small business. So we wanted to make videos growing up. This is really kind of for my mom. She does everything with paper. And I can pay for that. It's not as easy as so we wanted to do something that just make that easier.
Awesome. Perfect. Thank you guys.
It was so good that it was very long. We kind of like had to like take it out because it was just everywhere. It would have got too big, the road would have died. So now we have some medicine. You can probably wash this off and do it right now. Then we can go there. So I can go to my house for about 3 months, 3 or 4 months, and it worked. We can have some people out here, and you can call me back. We did this to make sure that it worked, that all the stuff that we did was really good, because it wouldn't be working if we didn't all this thing. We made sure it worked, brought it here to show everybody, and show that we were doing it right. And we did you guys already know a lot about like
Hey guys, can y'all tell me a little bit about your project?
We got tired of running laps around the residential building, trying to find an open washer. So this is our solution. We decided to use a physical component and a progressive web application. This is the progressive web app. Right now, you can't see the machine because we stopped paying for the back end once we had done our capstone presentation and we didn't see a need to continue.
We have 50 of them.
And then this is our physical component. Right here, there's an RFID scanner. In a perfect world, the RFIDs that we have would be paired to an individual account for each person. In an even better world, it might even be paired to the school RFID key that you have. Also inside of the physical component is a vibration sensor. The idea there is if somebody decides to buck the system and not use this physical component, the web app can still see if the machine is being ran or not. And then also down here we have these buttons which allow you to select how long you're going to run the machine.
But we do have cantaloupe.
Awesome.
It's also got SMS messaging, so when your laundry is done, it'll text you, say, hey, come get your laundry. And then if your laundry sits in the machine for too long, it'll text dorm staff, notifying them that somebody's laundry has been saved, so that it's just nobody's having to wait on laundry.
So y'all would get more laundry done? Awesome. Thank you guys.
Yeah.